Today we're going to talk about the beginning of Topic 12, which introduces us to algebra. So, Topic 12, Lesson 1. We're going to be discussing variables and expressions. In the past, we've been working with numbers and equations. Well, sometimes your equation or your circumstance changes when your condition changes. So we need things called variables and expressions to help us show relationships in the real world where things are changing. So your I can statement, I can or will use an algebraic expression with a variable. Use an algebraic expression with a variable. Okay. First, let's talk about what these definitions are. A variable is, and sometimes I just put this in parentheses in because we use the letter N. So, but you can use any symbol. It doesn't have to be a letter. It can be any letter or it could be any symbol. So the actual definition would be a symbol that stands for a number. Okay. And a little quote that I used to say is like, any number, any, like the letter N, any number goes in, as in the inbox, and a set number comes out. And what that means is if you're doing an in and out box, the in is the any number, sounds like any number, and it's in the in box for the most part. They can change that around and be tricky with you, but for the most part, it's in the in box. So let's look at a situation or an example of that. Let's say Johnny spends 15 minutes every day cleaning his birdcage. So let's write this down. Johnny spends 15 minutes each day cleaning his birdcage. And the amount of time he walks his dog kind of varies from day to day. So we'll say, and D minutes walking his dog. Now we just used the letter D because it's his dog. So that helps us remember. So we want to know how many minutes does John spend caring for his pets? Okay. So we have cleaning the bird cage, equals 15 minutes. And walking the dog is D, the letter D. So why do we use a variable? Why use a variable? Well, because the time changes every day. The amount of time that he walks his dog changes every day. So let's make a table. Okay. Let's say this is walking his dog, and this is, we know that every day he walks his dog and he spends 15 minutes cleaning his bird cage. So together, those things would give me the sum. So we know each day he spends 15 minutes. But what we don't know is how long he walks his dog. So let's say on the first day he walked his dog 10 minutes. The next day he walked his dog 15 minutes. The following day he walked his dog 20 minutes. Each one of these are going to be 15 plus 10, 15 plus 15, 15 plus 20. So the total time it takes for him to walk his dog and clean his bird cage, which is taking care of his pets. These are the sums for each day. We had to have a variable because the amount of time he walked his dog changes. We had to have an operation here, so we could put those two together to make an expression. We don't have an equal sign because it changes whenever D changes. Okay? So let's look at our second definition, algebraic expression. An algebraic expression is a mathematical phrase, and it's just like a sentence in math. If it's a phrase, it's not a complete sentence. It's a mathematical phrase that contains a variable, some number that changes, and at least one operation. Okay, I'm going to pause. Okay, another example. Let's say our variable, we're going to use the letter N, which sounds like any number. And our expression is going to be 23 times 3. Okay. So let's draw our table here. And it's probably more space than we need, but that's okay. So here's our space for what N is. And then 23 times N, which actually, if I go back, I'm looking at my notes, but I think this is incorrect. This is supposed to be 23 times N. Okay. And then we have the product. You could call this the total, but you couldn't call it the sum anymore because it's the product. So let's say n is 3, or n is 5, or n is 7, or n is 10, or n is 12. Okay? 3 would be 23 times n. 23 times n would be 69. 23 times 5 would be 115. 23 times 7 would be 161. 23 times 10 would be 23 plus a 0. 23 times 12 would be 23 times 10, which is 230, plus 23 more. Plus double the 23, because you have 2 more. I'm sorry. Let's see. 23 times 12. Yeah. Would be 23 doubled, which is 46, added to 230. So that would be 276. So let's look at the math we used for this. The first one was 23 times 3. The second one was 23 times 5. The third one was 23 times 7. 23 times 10 is 23 times 1. Place your 0. And then 23 times 12, we used a little mental math, and we did the 23 times 10, and then we did 23 times 2, and we added them up to find out what the 12 was. So this is an example of how to use an algebraic expression and solve equations that will be changing when your value of n changes. We would say this is the n box, this is the operation, and this is the out box. One very important thing that you need to remember is you always read from left to right and from top to bottom. For example, if you have an in and out box and it says 3 and 15 and 5 and 5 and 25 and 10 and 50, well, our pattern is multiply times 5. It works 3 times 5, 5 times 5, 10 times 5. But I had to read from left to right, so our expression is going to be n times 5. But let's say it's this way. And we have 35, 7, 50, 10. Let's make it 15, 3. Okay? If I'm going from 35 to 7, 50 to 10, 15 to 3, I'm dividing by 5. So if you notice, I had to read this direction, and I'm dividing by 5. So this would therefore be n divided by 5. Very important that you always read from left to right and top to bottom, or you will get the incorrect operation. Okay? That's the end of the lesson. You can finish your notes. Have a great day.